Wow, that was quite the introduction movie. Never had an introduction movie like that before. That was fun. That was different, and now I feel a little bit more on the spot for being the only thing standing in between, well, all of you and the movie, since we're all really here for a movie, right? Not just for a tech conference, especially given the movie that it is. But one more to go. I hope everybody's having a good time here so far at Stir Trek. For this last slot, to wrap it up, we're going to be talking about managing code using Microsoft's Azure DevOps. So really focusing on the continuous integration aspects of it all. As for me, I'm Jay Harris. I live in Las Vegas. I spent 14 years living in Michigan, but last 2 now in Las Vegas. I have my own software consulting company, Arana Software, in addition to being an MVP and a Microsoft Regional Director. So a lot of this stuff is things that I do on a daily basis, systems that I work with on a daily basis. And I certainly don't want you in any way to think that I'm here promoting Microsoft's platform, Azure DevOps, in any way because I'm some sort of Microsoft shill. I'm not. I've used many continuous integration platforms over the years, and I honestly have come to like Azure DevOps the most. I didn't always, but they've done a tremendous amount of work for it, and certainly now it's my favorite of the continuous integration platforms. And for my consulting company, we've migrated everything over to Azure DevOps. It's the only one that we use. We're no longer using Travis. We're no longer using TeamCity. Back in the day, it started on, what was it, Cruise Control, but that was like a decade ago now. So we're using Azure DevOps for all of our continuous integration stuff. But of course, first we really need to talk about what continuous integration is. We need to understand this concept before we really dig into the platform itself. Continuous integration is really about getting all of our code to play together in the same sandbox. If you think of the production environment and you think of our source control repository as a sandbox, we're constantly contributing new information, new data, new lines of code, new functionality into that sandbox. And our stuff needs to be able to play nice with everybody else's stuff. Everybody on the team, our things, our toys need to play together nice. We all need to work together well inside of the same sandbox and not be, I don't know, kicking over each other's sandcastles and throwing sand in each other's faces. So continuous integration is really about, well, exactly as the name implies, continuously integrating the new additions to our application, whether that be data, source code, whatever, continuously integrating our contributions into that same sandbox. And doing it continuously because it's a lot worse if it's not continuous. We're going to have to do it anyway. We're always going to have to do it anyway. And this concept has come out of the days of old when we might go off on our own to implement some sort of new feature in the application, and let's say it takes 3 weeks. And at the end of the 3 weeks, we try and get all of our changes merged back into that centralized source code, which, who knows, back then it might have just been a file share on a network somewhere. We hold all of our source code and trying to get it all to play together. Let's say I'm adding, I don't know, new functionality on user credentials, on being able to log into the site. And you're adding new functionality about user profile, because we're adding user management as a part of this sprint, this iteration. Well, of course, one of the very first things that I'm going to need to manage login credentials is a user class. And one of the very first things you're going to need is a user class. If we're not constantly integrating, sometime weeks from now, I've created a user class and you've created a user class, and they might be in different folders, they might be in different namespaces, they might be in entirely different projects, and that's going to create a lot of collision. Let's say they're not in different folders, in different namespaces. We luckily created the same file with the same name using the same namespace, but you need an email address for your profile management. I need an email address because that's what we're using as a username. I might have just called it email, whereas you've called it email address. Or we both might have called it email address and I used a lowercase a. All of those minor differences cause a lot of conflict, a lot of struggle when we're trying to get your code base and my code base to all play nicely in the same sandbox. Perhaps another good analogy is just thinking of the stuff that you were working on the previous workday. You probably know what you were working on yesterday, Thursday, at your office. You might have a little bit more of a struggle come Monday morning, because it's been 3 or 4 days, on what you were working on last Thursday. If you are about to kick off a vacation, you're going on vacation to the Bahamas for 2 weeks. 2 weeks from now, you're going to come back and you're really going to struggle to remember exactly what it was that you were working on last Thursday. The longer the deviation from that centralized point, from the baseline, if you want to call it that, the longer that deviation, the more struggle it is to get back into that space, to get everything normalized again. And that's really where continuous integration comes in. But there's 10 main components of what continuous integration is, what makes up this concept of continuous integration. First and foremost is source control. Number 1, maintain a source control repository. I hope in 2019 we're all at this point. When continuous integration first came out conceptually, not everybody was using source control. But then again, some of the best source control options that we had were Visual Source Safe, which some of you may remember Visual Source Safe was not a whole lot of fun. It was pretty brittle. It was pretty error prone. But we've come a long way. And this really doesn't matter what type of source control your system is using, whether it's Subversion or Git or Mercurial or TFS or something else, as long as there is one, as long as you are using a centralized source control repository to manage all of your code. Number 2 is automating the build, is making sure that the build of your application is self-building. That's not necessarily automatic, but it's certainly automated. So with this, maybe one command, one button click, something will kick off the entire process that will compile or transpile or whatever else you need to do to turn all of your source code into a functional or deployable application. Number 3, just like it needs to be self-building, it also needs to be self-testing. This is going to be through unit tests. Automated tests that we can execute that'll analyze the code and identify what works and what doesn't work. Now, this isn't necessarily associated with TDD, separate from TDD. Of course, TDD being test-driven development and trying to write the unit tests prior to writing the source code that the unit test is going to run against. Continuous integration doesn't care if you wrote the test first or if you wrote it last. It has no concept of that because ideally when you're committing new code into that source control repository, you're committing the implemented source code and its unit test at the same time. The order that they were created doesn't really matter because from the source repository's viewpoint, they were both created at the exact same moment. So this isn't really a TDD thing, just as long as you do have tests. Number 4, frequent merges. Officially, this one is everyone commits to the baseline. In Git, that would be master, or whatever your mainline is. Everyone commits to the baseline every day. Now, my argument is it's nowhere near enough. We're going to predominantly be creating a lot of source code in a day. And just having that as one big giant save is going to be a little bit horrible and still have a lot of pain integrating it all in together. So frequently, merge your source code into that main line, into that baseline, into the master branch as frequently as possible, several times a day. Number 5 is every commit against that baseline needs to be compiled on an integration machine. This one is really to eliminate it works on my box. We've all heard of it works on my box. We've all been victims of it works on my box. We've all been the culprits of it works on my box. We've all created some sort of new class in, I don't know, a .NET application, let's say. And we created the new class file, and we saved the new class file, and we committed the new class file, but we forgot to add it to the project file. So there were no changes to the project file, and when Visual Studio went to compile this new thing on someone else's machine, it didn't work because that assembly didn't have your new class. Even though the file was on disk, the assembly didn't have the new class. Or vice versa, we did save the new project file and committed the modifications to the project file, but forgot to commit the brand new class file. And things broke because the project file says, hey, Jay, you're supposed to have a user class in here, but I can't find it. And the compile is broken. Of course, my machine has the changes to the project file. My machine has that new class file, so it works just fine on my box, but not anywhere else. So the point of having all of these commits compiled on an integration machine is to eliminate that it works on my box. Because my machine, my development rig, is not the point of truth. The point of truth is that integration machine that's processing every commit. Number 6, feedback. Everyone can see the result of the latest build. Everyone. Everyone on the team, not just the developers, everyone. The graphics designers, the testers, the project managers, I don't know, the sales staff and the executives if they need to. Anybody that for any reason would need to see the status of this latest build, whether it's successful, whether it's green, or whether it's red and failed because a compile error or unit test failed because the test environment is down. Who knows? Whatever reason, that status needs to be available to anybody on the team. Having this information readily available, having those builds be very informative, gets rid of a lot of the communication breakdowns and other failures. If I forgot to add that user class, well, everyone can find out from the integration machine that Jay broke the build. Long before you go down and pull all of the changes from source control, long before you get latest from source control, and now it's also broken on your box because you don't have Jay's missing user class, you can have an email or something, some sort of a notification that says, hey, don't pull latest because Jay broke the build. All of that information is readily available, and it can keep things from creating blockers. Number 7. That feedback should also be very fast. So number 7 is keep the build fast. That build process should be as fast as possible. Fail fast, get information to anybody, everybody, as quickly as possible. Good example of where this isn't happening. Let's say you have your final commit to some new feature that you've been working on for weeks. But we didn't make the build fast. The build takes a half an hour to execute. So you've committed your source code, you've finished your feature, you've gone into whatever your issue tracking and story tracking, task tracking system is and say, hey, I finished this feature. You've moved on to what's next. But you broke the build. You don't know it for another half an hour. You're a half an hour into coding whatever next feature, or maybe it's the end of the day and you're a half an hour into going home. And the build is broken for everyone else. It's probably better if you're on the way home, because if you're a half an hour into some other new feature, you're a half an hour into other code changes that probably aren't stable, and your headspace is nowhere near that feature that you were just working on, that feature that you were just finishing. You erased all of that temporary memory and moved on to the next thing. So it's going to take a lot of extra work to, well, integrate your mind back into that previous headspace and go and fix the build. So keeping the build fast helps keep things moving forward as quickly as possible. Number 8, the build has to be distributable. Make it easy to get the latest distributable for the application, the latest deliverables. Maybe that's an easy way to get at the finished website. If you're building a desktop app or a mobile app, an easy way for you to get the latest bits, the latest version of the application, so that, who knows, perhaps the testing team, they can easily get at the latest application, the latest compile, and the test team doesn't have to go interrupt the developers, knock on their cue ball and say, hey, Jay, can you run a deployment for us? Can you give us the latest executable? Can you get us whatever? They already have ready access, and they're not slowed down having to search for it, having to wait for it, and others aren't slowed down through the interruptions of having to create it. So make it easy to get that latest distributable. Number 9 is testing in a clone of the production environment. So making sure that whatever system that you're testing this code again is as production-like as possible. Ideally, it's an exact clone of production. Obviously, some things are probably going to change. It might be, jharris-dev.com instead of jharris.com, who knows? So a slightly different URL. But ideally, it's going to have all of the same systems, all of the same infrastructure, even if some of the configuration components are going to change from one environment to the other. Now, I recognize that's not always possible. In many cases, it might be cost prohibitive to create a test environment that is really a clone of production, because production's massive. Production might be 16 load balanced servers just on the web tier. Who knows? But at least with that production-like environment, it needs to have all of the same systems. Can't have 16 load balanced web servers? Okay, at least have 2 load balanced web servers. So as a part of the testing process, you're still testing load balancing. You're still load testing, or you're still testing affinity. You're still testing and making sure that those sessions are going to continue to work. Making sure that if there's an SSL certificate on the production environment, that there's also an SSL certificate on the test environment. So any of your SSL-based code isn't being tested for the first time in the production environment. So making sure that your test environment has all of the systems that production has and is as production-like as possible. And finally, number 10 is making the system self-deploying. Automating the deployment. So just like we have one individual click or one individual command that can kick off the compilation process, we have one individual click or one individual command that can kick off the deployment process to our production environment. All of this is because we as software developers know that largely computers are going to execute some set of instruction the exact same way every single time. And largely, humans are absolutely not going to do that. We certainly, if we're doing a manual deployment to our production environment, we might have some exhaustive script of bullet points, some crazy dance that we have to perform to execute the deployment to the production environment. And once in a while, we miss a step. Once in a while, something goes wrong, because we're human. But the computers are going to execute it the same way every time. If we don't properly implement that deployment step in our automated scripts, it's going to deploy it wrong every time, not just once in a while. So automating the deployment. Now, all of this is about continuous integration, and I'm sure you've also heard the terms about continuous delivery and continuous deployment, and are wondering, what's the difference between these? Aren't they all just kind of the same words? Well, yes and no. So with continuous integration, the core tenet of it is automating all of these systems, automating the compile, automating the testing, automating the deployments, automating the feedback, but not necessarily having automatic compiles and automatic testing and automatic deployment. So continuous integration will have automatic builds, and automatic testing, unit testing against a commit. Add in continuous delivery, and now we're also talking about automatic distribution of the deliverable. So it's not just easy to get the deliverable, it's automatically created as a part of continuous delivery, and then continuous deployment takes that automatically created deliverable and automatically deploys it to perhaps even the production environment. So you make a commit, and there might be some minor human intervention, like an approval process, or while we wait for the test team to do their thing, do their quality testing against this new application. But at the end of the day, other than some minor human intervention under continuous deployment, that commit automatically makes its way all the way to production. So we're going to run through this stuff using Microsoft's Azure DevOps. There's a lot behind Azure DevOps. So there's issue and story and task and bug tracking, Scrum and Agile board tracking. There's certainly source control repositories using TFS or Git. There's test management. There is artifact and feed management for doing things like having your own private NuGet package feed. But for here, we're only going to focus on one aspect of the suite that is Azure DevOps. We're only going to focus on build pipelines and release pipelines. So to make that happen, we have to start with one prerequisite. Our step one is, of course, that very first step inside of continuous integration. We have to have some sort of source control system. Azure DevOps has it available to us. We're not going to focus on it right now, and we can certainly use other source control systems like Bitbucket or GitHub or anything as long as it's available from the internet. That's not to say that it's open source. You can certainly need some sort of credentials or personal access token in order to be able to access your account on GitHub, so it can still be a private repo, but it does need to be available accessible via the internet, not hidden behind some sort of firewall to use the Azure's DevOps systems. Particularly when this video releases in, I think they're all supposed to be online by May 31st, by the end of May. So if you want to run through this stuff later, there's a repository on my GitHub account, jharriswack simple-ASP.NET Core. It's just a very simple application, a single controller with one unit test, and we're going to be using that for the examples here with these demos. So after that prerequisites, we can get into the actual integration itself inside of Azure DevOps. Step one is making sure that we have a source control repository. Step two is automating that build, making sure that everything will automatically compile the system, automatically prepare the system. Now, in many, perhaps most platforms of today, there's probably 3 steps to that. Number one is going to be getting the latest source code from whatever our source control system is. Number two, that's going to be getting all of the latest packages, whether those are NuGet packages or Yarn or Bower packages, whether those are NPM packages, getting the latest Ruby gems, some sort of package system for our third-party libraries. So restoring all of those third-party packages that we use, and then doing some sort of build, whether that's compiling or transpiling or whatever that we need to do to prepare our source code into an actual application. So for this step two, we're going to go through connecting to a repository, personal access tokens for connecting to a GitHub account, what those pipelines and builds are, then we'll follow up with those last 2 steps, the package restore and the project build. So I have an account here on Azure DevOps. I've created a master project called Azure DevOps, and one of the first things that we're going to need to do is go into the list of pipelines. So we'll go through the build pipelines, and obviously we haven't created one yet. So we're going to create a brand new one. Once we're into creating that new account, the very first thing we need to do is select a source control system. Here we're going to create a connection over to GitHub. I'm just going to name it my GitHub connection. I'm going to go through authorizing that connection from Azure DevOps into GitHub using a GitHub personal access token. You can get that. You can set those up inside of the settings of your profile on your GitHub account. After it's connected through my personal access token, I'll set up the repository. What's the path to the repository that I have? Simple ASP.NET Core, and we're going to use the master branch as our default branch. And then we're going to move on into the tasks, the jobs of actually making this thing go. Okay, we're connected to our source control system, but what do we do with it? We've created the first of those three. We've connected to our source control systems, and with that, it's going to automatically pull down the latest source code every time it does its magic. But now we've got to get into, okay, what do I do with this big, massive blob of text on this source control repository? There's a lot of different jobs that we can do. We're going to start with just an empty one. So inside of this empty job, it automatically names it after the project that we've created. So we've got Azure DevOps-CI. We're going to rename that our simple ASP.NET Core project. Also, depending on the project that is, we might want to change the agent pool. Back when I recorded these demos, the most recent agent was a hosted Visual Studio 2017 one. Certainly there's going to be 19 ones, and Visual Studio 2017. This is essentially the VM that your code is going to be built on under the covers. You're not going to be able to use Windows and Visual Studio to compile your iOS app. So maybe you need a macOS agent pool, essentially a macOS VM. But for here, with this code sample, we're going to stick with a VS 2017 build agent. From there, we're going to go into the agent job. The job is the set of tasks that we're performing around some work that we need to do. We can have many jobs that are a part of a build pipeline, and they can run in parallel if we need them to. The tasks inside of a single job are all going to run in series, which is what we need in this case. A job can also have a separate job agent, but in this case, we're just going to inherit the type of job agent that is going to be on the previous screen on the build pipeline. Okay, so from here, now we need to set up that restore project to restore our NuGet packages. We're going to choose a .NET Core build task. We're going to set its command not to build, but to restore. We're going to need to do the same thing for creating our build task. So we'll go back to that plus sign, we'll add a new task, another .NET Core task, and we're going to keep its command on the default build. These could be together, because if you just run build, build is also going to automatically run a restore as a part of its process. I like to keep these as separate tasks, because then if it's all underneath one task, if the build task is doing everything, including the restore, if I get an email that says, hey, the build broke, I've got to start reading through the log file to identify where and why the build broke. But that email will say, hey, it broke in the build task. If I've separated out the restore into a separate restore task, I can tell quickly from the email, hey, this broke in the restore task versus broken in the build task. And I know if something broke in the build task, it's just about compile and not because NuGet.org was down. However, since build will also by default run a restore, and we already did a restore, we need to modify those arguments to add -- no restore. It's one of the command line arguments for the .NET Core tools, so that we can say, hey, when you're running this build, don't also run a restore, assume that we've already got that covered, because we did. Now, we also want to add the build configuration, because this is going to be production-like, so we want to make sure that this compile is in release mode, not in debug mode. So we'll go into variables and add a new variable called build configuration, set its value to release. That way, everything can use this same variable, and if we, for some reason, want to change things over to debug, we only have to change that variable in one spot, and we can use that variable as a variable substitution everywhere else inside of our build pipeline. So we'll go back into our pipeline, modify our .NET build task to add configuration, $n build configuration, and that will get substituted with release mode. Save and queue. It'll save our build configuration, go queue up a new one, even though we haven't committed any new code yet. It'll automatically start doing its thing. Pull down the latest source code, run through the .NET Restore to get all of the latest NuGet packages. It'll run the .NET build, run the compile, and we're done. It's green. And also for accessibility, that green circle has a check mark in it versus an X. So this can be printed in, I don't know, black and white. Or for vision impairments, you can still have visual cues beyond just color. We can also go into the summary task to learn about this build itself. What changes were included? Who kicked it off? Did it run? How long did it run? All of the information that we need. So far, it's not sending any notifications yet, but we'll get to that point. So we've created a new pipeline. We've connected it to GitHub with our access token. We've set up all of those pipelines, given them the appropriate names, set up our restore and our build tasks. That step 2 is done. Step 3, making the build self-testing. Obviously, this is going to be running those unit tests. So inside of those, that same screen that we were on before, the summary task, we'll go in to edit our build pipeline. Inside of our build pipeline, we'll go in to add another task. The same .NET Core. And we'll set this one's command to test. Now, .NET's tool is automatically going to run against every single project file inside of the solution. We don't want it to do that. We do for the restores and for the compiles, but we don't want to do that for our tests. If we try and run .NET test against our web project, well, there's no unit tests inside of the web project. The unit tests are in the web.test project. So we do need to give it a glob, a path to all of the appropriate test projects where we can find the unit test. You can use a glob if you can get that all to do one. You can enter in multiple lines for the test projects individually if you wish. And just like how build will automatically restore, .NET test will automatically restore and build. So we need to set the command line arguments to break those out, no restore, no build, and still set the build configuration. Because even though this isn't taking care of the compile, so it's not compiling in debug or release mode, the assemblies that get created are in 2 different directories. They might be in bin/debug or bin/release. So we still need to give .NET test the build configuration so that it can figure out which path to go look for the assemblies to run the unit tests against. Save and queue. We can watch through the progress. It spins up the appropriate agent. It runs through all of that same stuff. The same restore, the same compile, executing all of the unit tests now. That next to last row, that next to last check mark is .NET test, which passed. And now, in addition to the log and summary tabs, we also have the test tab, which shows the status of all of our unit tests. Hooray, there are no test failures. So with step 3, we edited the pipeline. We added the .NET Core test task with all of the appropriate test paths with its appropriate arguments so that it's not also doing a restore or a build. Save and queue. Step 3 is done. Now, for testing, if some conditions specifically for .NET, if you are doing multi-targeting, so you're compiling against both .NET Core and full framework, perhaps. If you're doing that, make sure that you run your unit tests against the .NET test command, not your MS test task, not the Visual Studio tasks that are in Azure, not your NUnit tasks that are in Azure. Use the .NET test task, because that's the only one that will execute your unit test against every single platform that you're compiling against. So .NET test with one task will run your unit tests against full framework and run it against .NET Core, whereas all of the other ones will only run one of those platforms at a time and pick one if you didn't specify. So for multi-targeting, use the .NET test task. This would also be where you add in any other testing add-ons that you may wish. Like if you wanted stuff for test coverage, or if you wanted to run security analysis. Maybe it's going to analyze all of the NPM and NuGet packages that you're pulling in because we have a known vulnerability if you're pulling in this specific version of this specific package. This would be the place where you would also add in those additional tools. Step 4, everyone commits to the main line every day, or really as frequently as possible. This is that frequent merge test. This is also the only human element. There's not going to be any automated system that we can add in that's really going to force you to commit multiple times a day. That's up to you and your own discipline. So this one really is exempt from any inclusion in how to use the platform. This one is just up to you and your own discipline. Step 5, now that you've made those frequent commits, making sure that every one of those commits is compiled through the continuous integration process. Everything should go through the build. We do that through build triggers. So in that case, well, we're talking about wiring in this demo up to GitHub. So there will be a commit hook set up when we configure the project. There'll be a commit hook inside of, configured inside of github.com that whenever we push code to github.com, it's going to execute that commit hook that sends a notification over to DevOps and say, hey, we've got new code, go compile it, go do your thing, go get latest and compile. So those are all going to be in build triggers. Those build triggers can also go against individual branches, not just master. So I would recommend running it against all of your branches if you're making feature branches and hotfix branches and issue branches that are all branched off of master. You can run continuous integration against those as well. And perhaps even if you're using pull requests on your, at your workplace, or you have an open source library that's using pull requests, you can wire those PRs into the continuous integration process as well. So with step 5, we're going to go over commit triggers, and we're also going to go over schedule triggers. Back to that test result page that we just left off on, we're going to go to that edit button to edit our build pipeline once again. Here we're going to go into the Triggers tab to enable continuous integration, to check that box. That is where that webhook is configured. That's where we need the appropriate permissions inside of github.com so that here, when we save this, Azure can use that personal access token to log into GitHub on our behalf and set up that appropriate webhook. Now there's that second option there of batch changes while the build is in progress. I recommend leaving that unchecked. So that one is, let's say all 10 of us are committing code at about the same time. Maybe it's 4:59 and we all want to go home and we're all committing our changes at the same time before we go home. Someone's going to go first, and the very first commit, the very first push into Git is going to kick off the build process. This build is pretty fast, but it still takes about 2 to 3 minutes to run through the entire process if I wasn't fast forwarding the screen captures. In that 3 minutes, the other 9 of us might have also committed code. Doing the batch changes, having that checked, once the first build is done, the system recognizes, hey, there's more, and it'll just pull latest again. However many additional commits that has, it'll just pull latest again and run the compile against that. The problem is, if one of those 9 commits broke something, we get the build failure, but now we have to do additional triage to figure out which of the 9 broke the build. If you leave that unchecked, it's going to, with those 9 additional commits, it's going to step through them one by one, running through the continuous integration process on each of those commits one at a time. And that way, if there is a broken build, we know exactly which commit it was and reducing our triage time. Now this is configured to only run against master. We can change that branch specification simply to a star, and it will now run the continuous integration process against every single branch that we make in Git. So again, those feature branches, issue branches, hotfix branches, whatever. We can go into pull request validation and enable this for pull requests if that's appropriate for our system. With the same thing, changing this to any branch specifications. Most PRs are going to go back against master, but not all of them. Some of your PRs might go against a specific feature branch. Who knows? We're probably still going to want to run CI against all of the branches, even if master is just the common one. And last is going to be scheduled triggers. So we can go into scheduled triggers, and we can set up a new scheduled trigger. This might be a nightly build. In this case, it's going to automatically execute every weekday at 3 o'clock in the morning. Now here, there's also that checkbox to only schedule builds if the source or pipeline has changed. I recommend unchecking that box, because it's more than just your own source code that could change from night to night. Let's say, going back to that example of inside of the testing phase, you're running security analysis on your third-party packages. Today, we might not know that there's a security vulnerability inside of package X. That might be identified tomorrow. But today, tomorrow, we're here at Star Trek. We're not committing new source code, so the source code hasn't changed. The pipeline hasn't changed, even though we've identified new information. So by unchecking this box, we're going to run that nightly every weeknight at 3 a.m., whether the source code has changed or not, which means we're also going to run the security analysis on the system, whether we've changed source code or not. And long after we've finished a project, and 2 months later, when no one has touched source code, they've identified a security vulnerability, that nightly build will fail and say, hey, just so you know, we found a security vulnerability in package X. You should probably take a look at it. Maybe upgrade to the latest version of the package. Who knows? So another good option for your automated triggers. Save it, and it's on its way. So step 5, we edited the pipeline, went to the triggers tab. We set up the continuous integration triggers, not batching changes. We enabled it for all branches, as well as for pull requests. We set up a scheduled build for 3 a.m., a 3 a.m. nightly on weekdays, saved it, and went on our way. Step 6, everyone can see the result of the latest build. This is that feedback. This is keeping things informative. This is our notifications, whether that be email that we're receiving in our inbox. Oftentimes we'll see with open source systems, open source projects, this could even be a badge that's on the README for a GitHub repository, and Azure DevOps includes all of that stuff. So for badges and build notifications inside of Azure DevOps, back to that same screen that we just left off on, we'll go into options, and options right there, there's nothing to modify because this comes by default, includes all of the URLs for your build batches, and you can embed those inside of your markdown file, your README, if you wish. These also include inside of that URL a branch specification. So if you don't want to run them specifically against master, you want to run them against some other specific branch, cool, you can do that with some simple text editing. Now for the notifications, we'll go back to the project's homepage that lists the 2 builds that we had so far, one for just the build and one for build and test. And we'll go to that gear icon on the bottom left and go into the project's settings. Inside of the project settings screen, we'll also go into the notifications tab. And inside of that notifications tab, we'll go to the button on the top that says new subscription. This is how you would set up a new notification inside of Azure DevOps. So we'll go to new subscription. We'll set it up for if we received a build failure. Select a build fails. Gives us the screen for the rest of the configuration. Inside of that roles drop-down, we'll configure this for who do we want to notify. Do we want to notify who requested the build? Do we want to know who we can configure it for who made the code change in case the build was manually queued? We can notify the committer of the source code that, hey, things were broken. For this example, we're just going to set everything and notify everybody. when there was a build failure. Save it and move on. So, step 6. Again, go into that Options tab to view the badges, to view the URL for the build badges if we want those status badges. We can also go into the Notifications tab within Project Settings to add notification subscriptions. And there's lots of different events that we can run on. We can do things on if it's failed. We can do things on if it's succeeded. Do things on if it changed the status rather than just, yep, it still broke. There's a lot of things that we can run those notifications against. Step 7, keeping the build fast, getting that feedback fast. This, of course, is really going to be all about our time to done within the system. We can do that by modularizing our code base, of really just compiling the stuff that's necessary, or executing the tests and steps that are absolutely necessary. But this can also come into timeouts on those jobs themselves. Sometimes things can get really slow and really hang things up. I don't know, maybe our internet connection went super slow and now it's taking forever to pull down our latest NPM packages. I don't know. So we can set those timeouts certainly inside of Azure. Going back to the pipeline page from our project settings, going into that build, editing the build pipeline once we get to it. Hit that edit button. From there on the pipeline itself, so that build task on the job, we can go into the job level task and set up an appropriate timeout. Let's say on this one we're going to set the timeout to 5 minutes, 300 seconds. If the build as a whole takes more than 5 minutes, again, this one should take 2.5 minutes. If it takes 5 minutes, something went wrong. We can also set it on individual tasks, like this one, inside of control options. If the compile itself takes more than 3 minutes, something went wrong. The rest of the time is going to be consumed on our restoration process and our testing projects. 0 is no timeout. 0 is the default for all of these, but you can override them, and I recommend that you do. Set something high where this shouldn't be achieved, and if it is, something has absolutely gone wrong with the build pipeline so that we don't have things hanging around absolutely forever. Save and move on our way. So we went for step 7 for those timeouts. We edited the pipeline, went into the task tab, and added a timeout for both the job as a whole and for individual build tasks, and we saved. Now we've gone through build status. We got that compile and the feedback on our build. We have kept it fast, and now we need to start getting into the delivery aspects. So we need to make sure that we have this easy to get the latest distributable. Number 8, make sure that the latest deliverable is easily accessible by everyone. Certainly for a website, this might be a zip file or some sort of MS deploy file, at least in the .NET world. There are many other options. In the .NET world, we certainly can package this into a NuGet package if it's appropriate for our project, appropriate for our library. We can even host that on an internal only, on a custom feed within Azure itself. So that NuGet package that we created can be hosted on an internally accessible feed on the Azure platform. We're not going to go over that one today, though it is available. As far as integrating this stuff, we're going to go through publishing that output, the build output, the compile output. We're going to convert that into an artifact and make sure that that artifact is available for download by humans, as well as later inside of our release pipelines. So we're going to go add another .NET Core task. We're going to set that one to publish instead of restore or build or test. Just like before, we need to set up no build and no restore and set up our appropriate build configuration. We do need to add one more argument, though, the output. This uses build.artifact staging directory, which is a special variable inside of Azure DevOps. So all of the output of, well, in this case, your web project, take your compiled and your prepared web project and put it in this well-known directory for the build. we can use that in our next step, where we go to add another task. This one's going to be publishing an Azure artifact. Page finishes loading. It's all the way at the bottom. Publish a build artifact. We add that in. Come on. Too far. We add in the appropriate build artifact. The path that we want to publish is that same build.artifact staging directory, and then we're going to give it a name so that we can find it inside of the interfaces and wherever else. This one, we're just going to call it drop. You can call it whatever you want. Save and queue so that it goes through its thing. It goes through that appropriate build process. My movies aren't autoplaying for some reason. See, even on pre-compiled screen captures, you can still have demo failures. So run through all of the same stuff, initialize the agent, pull down all of the latest source code, do all of the same .NET Restore, .NET Build, .NET Test, .NET Publish, which is our new task, and then getting that Azure artifact, that Azure DevOps artifact, all ready to go. Now, just as before, we add the logs and summary in test blade. Now we also have a new button for artifacts. That drop-down is going to be a drop-down that will populate with this specific artifact you just created. So right inside of that drop-down will be drops and our zip file, our MS-deploy zip file that was created by the .NET Publish command. So we went through, added a new step, a .NET Publish step with all of the appropriate arguments. We set up our publish build artifacts task, save and queue, and move on. Step 9, test and a clone of the production environment. Making sure that this is a production-like environment. So with these demos, our production environment is going to be an Azure Web Service. So our release to test is also going to be an Azure Web Service. And this we're going to set up so that every commit is automatically deployed to the testing environment, at least in this demo. I'd certainly still recommend that. Now I know, well, what if the testers are in the middle of testing? Well, of course, I see that as an opportunity, because when you're deploying to production, what if your users are in the middle of using? If we can get to a zero downtime deployment in our test environment, that really opens the door for a zero downtime deployment inside of our production environment. So yes, I do recommend automatic deployments from commits into the testing environment. We're going to go over releases, artifacts, stages, continuous delivery with release triggers, and after release triggers. We're going to go into the release pipelines instead of the build pipelines where we've been hanging out so far. We're going to create a new release pipeline. That automatically creates an empty artifact list and our first stage and gives us a template list for our deployment to the stage. How are we going to deploy to this environment? A stage is essentially in an environment. There are a lot of options. We're going to, just like before, go with an empty option. We're going to rename this stage our test environment because for this demo, that's what it is. This is going to be our test environment. Now we need to go over to the left side on that artifact list, that dimmed out blue section on the left column, and we need to add an artifact. This is the thing that's going to get deployed. This is the thing that's going to get deployed everywhere. So we're going to select what we're going to deploy. Of course, that's going to be our sample ASP.NET Core build project, and we're going to want to go get the stuff that was out of that sample ASP.NET Core build pipeline. We're going to alias this release. We're going to say, hey, every time we need this to do this release, we're going to use the latest, or we're going to somehow specify it at the time that the release was created. Then we're going to go into the continuous deployment triggers for this release, and we're going to enable continuous deployment. We are going to set a branch filter on this, because remember, continuous integration is building every branch. We don't want to send every branch to the test environment. We only want to send the master branch to the test environment. So we're going to set that one to the default branch only. Next, we're going to go into modifying the tasks for the individual stage for our test environment. We're going to add a brand new task for an Azure app service for that task, because that's where this website is going to go. Set up a new Azure app service, add it to the list of tasks, to the job for this release pipeline. We're going to specify our Azure subscription and our Azure app service name. This is going to be workshop-dev for this instance. And then finally, we need to specify the artifact that we're going to publish. So in that artifact list, it's going to come up with a pop-up where we can select from that build project, from our sample ASP.NET Core build project, we can go into that drop folder and say, this zip file is the thing that you're going to deploy to this environment. Save it and move forward. Next, we're going to go and create a release. Up in the top, as a part of selecting the release, we already know which build pipeline that we're going to do. So from here, we just need to select the build number, because we're manually deploying one of those previously completed builds. So we'll select that build number and go. We'll watch the progress do its thing. You can see that the deploy is already in process to the test environment. It's running through in progress. Eventually, it'll step through, well, our 4 steps of deployment, and it'll just say green succeeded. So we've created that new pipeline, associated all the appropriate artifacts with it. We created our test stage, which is really our test environment on an Azure App Service deployment, and move forward, which gets us to our final section, step 10, automating the deployment. And in this case, we mean self-deploying, automating deployment into our production environment. Now, that one certainly might need approvals, and Azure DevOps supports that as well. So now that we've deployed to the test environment, maybe we absolutely want some human eyes on this. Someone's going to review this thing, run through some manual tests, some exploratory tests, some visual tests to make sure that the logo is on the right spot on the home page. I don't know, but some sort of human intervention. And then a human can come in later and say, yep, this one's good to go. We're okay to deploy this to production. So we're going to go over cloning stages, because test is already production-like, so most of the work for creating the production stage is already done, and creating the appropriate conditions to handle the deployment. So we're editing that release pipeline. Not editing the release. A release is one version. We want to edit the release pipeline to change how those all releases are managed. From there, we want to clone the test environment. So we hit that copy button, and it creates an exact duplicate of that environment, pulling over all of the appropriate configuration with it. We're going to rename that one to our production environment, because it is. And we're going to go into the tasks for our production environment and change our app service from using workshop dev to using workshop prod, because that's the differences in our production environment. We're going to go back to the properties from the stage itself and set up the pre-deployment triggers on one environment, our production environment, and we're going to say, hey, this one always comes after test. No matter what, nothing happens to here unless it's gone through test first. It has to have gone through test environment first. And then we'll also set up a post-deployment trigger, a post-deployment condition on the test environment that says, with our post-deployment approvals, hey, nothing can leave this environment, nothing goes beyond this environment unless it's been approved by Jay. So it still needs some human intervention. It doesn't automatically make its way all the way to the production environment. So we can, from here, go back to the build list. Now that it's all set up, it's all saved, we can go back to our build pipeline, back into the project that we were. We can queue a brand new version of this build. Of course, we haven't changed any code, so we're not running through the code push triggers, the source control commit hooks, but we can still manually queue a build and run through the stuff. We can still see the same build progress that's been set up on the build pipeline of checking through .NET Restore, .NET Build, .NET Test, .NET Publish. From there, we can go into the releases, and we can see now that we finished the continuous integration aspect, the build pipeline aspect, it's automatically deploying it to the test environment because that's what we told it to do. But now that it's done with the test environment, now we say, hey, there's a pending approval on the test environment stage. We can't go further. We can't complete the rest of this release pipeline without some human intervention. So we can hit that blue button, go into our pending approval page. It lists that, hey, all of this stuff is done. All of the information is available here on what was done. So since I'm the approver, I can hit that approve button, say, hey, this is good to go. And as soon as I hit that approve button, everything, our artifacts, our code, our application is allowed to leave the test environment and move on to other stages, which of course is our production environment, which is already in progress, and automatically deploying into production, done. Both environments have succeeded in their deployment. That's step 10. We added the release pipeline. We just cloned the test stage because we didn't have to go reinvent the wheel on our test or on our production environment because test is already production-like. So it's already got most of the configuration there. We just had to turn a few knobs. Set up all of the appropriate pre- and post-deployment approval configuration. And then we just needed to trigger a build. Or we could have just committed code. That would have worked just as well. So some anti-patterns. First of all, there are some anti-patterns that we can do in sort of this process that have to do with committing code. We need to commit frequently. This is most valuable when we're committing frequently. So we go back to that original scenario of you're working on user profile and I'm working on user credentials, I'm working on login. Whichever one of us creates the user class first, we can save that empty user class and commit it. Nothing else is using that user class, so even if that empty user class goes all the way to production, no one's going to care. It's not going to impact anything. But it certainly helps the development process because now we both have access to the same class. Now we both have access to the same class to add additional function, additional properties. We both need the email address property. So whichever one of us is first to create the email address property, it's just an empty dumb class that has one string property on it called email. We can commit that just fine. It's not going to break anything. But we know that I'm not going to have an email address that conflicts with your email property because we named it differently or we titled the casing differently. Also, avoid bottleneck commits. And what I mean by bottleneck commits is if you have some sort of policy that everybody has to commit before they go home. Because that means everybody has to commit, everybody's going to commit at 4:59 just before they head out the door. And inevitably, things are going to stack up, and we're going to have another half an hour before it works its way through all 10 commits that just went in. Someone's going to give up, stop waiting, go home, and then they're already halfway home and broken the build. So commit code when it's appropriate for you to commit code based on the code that you're writing. Don't commit code because the clock said so. Same with your messaging. Well, there are opposing anti-patterns for this, and that's minimal feedback or feedback spam. Hey, we're new to this continuous integration process, so let's turn off all of the notifications. Well, then you might as well not have it because you don't even know when you're breaking the build. Hey, we're new to this continuous integration process. Let's turn on all of the notifications. You know, most of those are just going to be noise for your process. And if you don't create a Microsoft Outlook rule that sends everything from the build server straight into the trash can, it might create one for you with a spam filter because you're getting spammed by the CI machine. Or if nothing else, you're going to create a Menta one of, oh, this is just from the build server. I'm just going to ignore that file, that message. So it's already lost its value to you. So avoid minimal feedback and avoid feedback spam. Spend the right amount of time to find what's appropriate for you and your team. And then finally, on triggering. So make sure that you don't enable batch commits. It's certainly valuable, even if it's going to take an extra few minutes to get through each one of those compiles. Let it do its thing so that if something broke, you know exactly what commit it was, and you don't have to triage and then avoid anti-patterns in building. Make sure that you build everything, not just a little bit. Compile the whole thing, but at the same time, don't add every single bell and whistle and toy just because it sounds fun. Don't add code coverage if you're not going to care about code coverage. If you don't care about the code coverage, don't even bother analyzing the code coverage, because that's CPU time that slows down the process and slows down how fast that feedback gets to you. It's still just noise. For more information, I made a bit.ly link for DevOps Pipeline, which takes you straight to Microsoft. Has some wonderful documentation, as they should, on their own platform. So you can go to DevOps Pipelines to get to that. And Paul Duvall wrote a book, Continuous Integration, Improving Software Quality and Reducing Risk. The book is getting a little old at this point, but it's not covering a specific platform. Well, maybe beyond examples, but the concepts haven't changed. So the concepts are still there and still valuable. So for the next steps, start small. Take just one of your projects. It doesn't have to be every project that's at work. Start with just one of the projects, put it underneath a build pipeline. You can start out at the free tier of Microsoft's Azure DevOps, a free tier for testing this stuff out and really kicking the tires and finding out some ways that you can really move your process forward, optimize your process, because really it's working towards automation. So you don't have to worry about messing up your dance of tasks that you have to complete for compiling or deploying the system. All of that stuff can be automated or maybe even automatic, which will, of course, greatly lead to improved confidence with how all of this stuff works. It makes those production deployments a whole lot less scary and a lot more awesome. Thank you.